Okay, welcome to Algebra 2, notes for section 7.2. And in this section, we're going to learn how to multiply and divide radical expressions. Now, the first rule here is that if you take a radical times another radical, you can combine it as one product. In other words, the radical of A times B, you multiply the radicands. So in the end, you end up consolidating these two roots and putting the product of the radicands underneath. So you multiply those numbers underneath. Now there's a couple ground rules. The indices have to match throughout, so you can't, for instance, mix square roots and cube roots. Now there are some other things that you need to watch out for. If you have an undefined first section and an undefined second section, in other words, you have non-real numbers for those parts, then the whole thing is undefined or non-real number. Okay, so let's put this to work here. What we have here is a multiplication, and we have two square roots, so we'll make one square root out of it. 6 times 42, you can do it on your calculators, 252. Okay, then you have to simplify this, and you're going to simplify it by pulling out a perfect square in this first section here. And we do that by going to the y equals key and typing 252 divided by x. Once you'll go to the table of values in automatic mode and cruise down the right-hand side. You'll see 36 on the right times 7. It's going to be down on the 7th line. And now that you got a perfect square in the front, you simplify it. So you get 6 root 7 here. Okay, an easier example on the right-hand side over here. Square root of 2 times the square root of 10. You can make one square root out of it, 2 times 10. And then you break it apart in a proper way. One way to think of this is you're putting it together because 2 and 10 is not, neither one's a perfect square. So you put it back together again, and then you take it apart with a perfect square up front, in this case 4. Simplify the square root of 4, that would be 2, and you have your answer. Now, if you type this on your calculator on the home screen and compare it with what you get if you type the answer on the home screen, you can check your work that way. Okay, here's another example. 4 times 32, we got a cube root on both of these. So we'll put it together here. 128 is what you get when you multiply those. And then you're going to try and figure out how to break it apart with a perfect cube up front. And if you do that, you're going to go to your y equals key, and you're going to type in 128 divided by x, and then jump to your table of values. And if you cruise down the right-hand side, you'll see 64 times 2 pretty quickly there. And 64 is your choice because it's a perfect cube. When you simplify the front, it becomes 4 cube root of 2. Okay, example 4, we have to be careful on. There's a negative there underneath the cube root. If it were a square root, we would say no real solution, but cube roots can actually have negative values underneath them. So we're going to just proceed with this. Negative 2 times 28 is negative 56. And if you go to your y equals key and display the factors of 56 on your table, you'll see that 8 times 7 is one of the ways of breaking apart 56. So 8 times 7 is 56. Now the question is, where do I put my negative sign? And the best choice is to put it up front, and that'll help you pull out the negative when you do it. This cube root of negative 8 is negative 2, and you get cube root of 7. Okay, example 5 also has a negative underneath. The radicand there is negative, but the problem here is we're not supposed to be using I, and the square root with a negative underneath it doesn't yield a real answer. So this whole thing is, we're just going to say no real solution here. If we were allowed to use I, we would find an answer. Now I'm going to give you another example over here. I'm going to call it example 5b. And I'm going to say square root of negative 2 times square root of negative 18, and you might think the way to go would be this. Now, don't write it down yet because I'm going to fix this. It's going to be wrong. Negative 18 times negative 2 is 36, and so you might think the answer is 6. Sorry, I said 6 but wrote down 3. You might think the answer is 6. But the problem with this approach is that from the very start, this problem's doomed. A negative underneath a square root or a fourth root or any even-powered root is no real solution. And if there's no real solution on both parts, it doesn't fix it to put it together. Okay, I'll do 3 more here, and then we'll punt to another video here. Okay, we're supposed to simplify this, assume all the variables are positive. Now, one of the nice things about that phrase, it says assume that the variables represent positive numbers, is that we don't have to worry about negative numbers in here. And it means that this expression here on problem 6 will be a positive value. And as such, we don't have to worry about absolute value bars. So this is kind of code for no absolute value bars needed. Okay, so no absolute value bars needed in these problems. And we discussed when to put them in the last section of notes. All right, so we have to figure out how to break this apart. Now, the way it works is like this. The 40, you're just going to figure out what perfect square is hiding inside the 40, and we've been doing that for a while, 4 times 10. But the x to the 9th, when you have an exponent, in this case 9, you want it to be able to divide by the index, and 9 doesn't divide by that little 2 that's out there. So what you have to do is go down 1 click at a time to get something that does divide by 2. So 9th power is too much. If you go down to the 8th power, that would divide by 2. So you put 8 of the x's up there, and the extra x goes in the back. Now, this front part here is a perfect square when you do that. Square root of 4 is 2. And this 8 divided by the hidden 2 there would give your new exponent of 4. And then we have the extra 10x, square root of 10x, that we have to just leave like that. Okay, the 80 breaks up into 16 and 5. And you can find that pretty easily. We've been doing this a little bit. You just go 80 divided by x on the y equals line. And you'll see that 16 is 5 clicks down on the right-hand side of your table of values. Okay, the next thing you do here is figure out how to break up the x to the 10, and we're in luck. 10 already divides by that index 2, so we're just going to put it all up front. But the y to the 5th, 5 does not divide by 2 without resorting to decimal points, so we're going to go 1 less than that and see if it works. You just go down by 1 until it works. So y to the 5th doesn't work, y to the 4th does. That divides by 2, and you got to put the extra y in the back where you can't do anything about it. The whole front should simplify. 16 square root of 16 is 4. Dividing the exponents gives us 5 on the x and 2 on the y, and we're dividing by the little number that's implied out there. And then you have your 5y there. Now, normally this part of it would have to have an absolute value around it. Anytime your index is even, like 2, and your resulting exponent is odd, you have to ensure that it's positive by putting bars around it. And normally we would do that, but we have these magical words up here. Assume that the variables are positive, and it means we don't have to worry about it. Okay, negative 432. We're going to find out how to break that up. And I actually don't know that one right off, so if you give me a second, I'm going to pull out my own calculator and do it. I'll describe what I'm doing so you can kind of repeat this process yourself. You go to the y equals key and type 432 divided by x, and then you jump to your table of values in automatic mode, and you want to cruise down the right-hand side, and on the second line you'll see the one we want, 216 times 2. That's a perfect cube. All right, now we got to handle these. Let's handle this x to the 8th. 8 does not divide by 3, so you have to bump it down 1, 7. But that still does not divide by 3. So then you go 2 units down, or you go 2 exponents down, and you're going to put x to the 6th there and the extra 2 x's in the back. You still have your x to the 8th, but now the front exponent divides by 3. Now this y to the 3rd is ready to go since 3 divides by 3. Okay, the whole front is going to be 6, that's the cube root of 216, x to the 2nd power, and y to the 1st power. And then we have the part of the problem, I affectionately call it the junk pile, that you can't do anything about. Okay, that takes us through the first 8 problems on the notes, and I'll pick up on example 9 in the next series.